Well, since it's so useful to have a polynomial in factored form to be able to tell its solutions and also the x-intercepts to know what the graph looks like, it's a good time now to review how to factor a trinomial. So one thing you might have learned in Math 1 or Math 2 is if you have a trinomial like that, you can factor it by seeing what multiplies to the last number. So in our first example, multiplies to 36 and then adds to the middle number, which in this case is 13. So I'm needing numbers that multiply to 36 and add to 13. Well, I can just kind of make a list of numbers if I want to that multiplies to 36. There's 1 and 36. Of course, that won't come anywhere close to 13. There's 2 and 18. Also pretty far off. 3 and 12. 4 and 9. And 6 and 6. I'm not going to require you to write this list of numbers down every time, but if you do get stuck on finding the numbers that multiply to 36 and add to 13, sometimes making a list is great. You can kind of tell if I'm adding to 13, I need numbers that are kind of close to each other, like 1 and 36 or 2 and 18 is clearly way too big. This one's 15. 13 is the one I'm looking for, and 6 and 6 would have been 12. So if you do not have a number in front of that x squared, if it's just a leading coefficient of 1, you can always just get to the right answer this way, and that gives you an x plus 4 and an x plus 9 is my answer for factors. Now, once you have it factored, you could find the solutions if you wanted to. So the solutions for this problem would be x would be -4 or -9, based on what we did in the last video. When I take it out of the parenthesis, I would technically be setting x plus 4 equal to 0 and solving for x by subtracting 4 from both sides. That's why it switches from a +4 to a -4. But I'm fine with you not writing this stuff here down and just saying, hey, I know if it comes out of the parenthesis, a -4 plus 4 will give me the 0 I need. And that helps you find the 0 or the solution. Now for the second one, same idea. This time notice you're multiplying to a -36. We'll do this one in a slightly different color. So I'm multiplying to -36 and I'm adding to -9. So I'm multiplying to -36 and adding to -9. Since I'm multiplying to a negative number, I know one of my numbers is going to be positive and one's going to be negative. I'm going to use the same list of numbers over here, but what you notice is now I can make one positive and one negative. Now, to have an idea of which one to make positive or negative, it's helpful to look at the number I'm adding to. Since I'm adding to -9, I know my big number is going to have to be negative because whenever I add integers, it takes the sign of the larger number affects the sign of the answer. So I can basically only have to consider situations where the larger number is negative. And now if I'm looking for -9, this one doesn't work because 4 plus -9 is -5. But this one does work. We'll box it in purple, and that should be your answer because 3 plus -12 is -9. So that gives you an x plus 3 and an x minus 12. On the last one, I'll pick one more color for it, maybe a nice gold color. On the last one, I have a x squared minus 36. Well, in this case, there is no middle number. So you can think of that as multiplying to -36 and adding to nothing. Well, to add to nothing, that pretty much means I'm going to have numbers that match. So the only thing that will do that is this bottom number, the 6 and the -6. And the truth is you can always use that shortcut when you have one without a middle term if it's just a binomial that's squared. And I can just say, hey, x times x is x squared, 6 times 6 is 36. But I just want to show you, if you think of it like a trinomial, it is consistent because a +6 and a -6 do add up to be a 0. And then your answers, of course, would be x could be -6, and that technically comes from the first parenthesis, and then x could be +6, which comes from the second parenthesis because I'm switching the signs on both of them. On this one, if I wanted the solutions would have been x was -3 and x was +12. So that gives you an idea of how you can factor to get solutions. And remember, those solutions are also x-intercepts, so I could sketch a graph of one like this even by just saying, hey, this goes through +6 and -6. So this is a pretty deep thing. And actually, when I'm sketching the graph, if it started off in standard form, remember this -36 was my y-intercept, so it would have crossed the y-axis way down there at -6, and the x-axis at your solutions of 6 and -6.